Welcome back to the class on electromechanics school. In this lecture, we are going to discuss about the power stage diagram of three-phase induction. The power stage diagram is nothing but a induction motor. We are giving a electrical supply. How that electrical supply will be utilized in the induction motor, that we are representing in one diagram. The diagram is nothing but a power stage diagram of a three-phase induction motor. So before going to the power stage diagram of three-phase induction motor, let me know what are the different losses occur in a three-phase induction motor, where exactly these losses will be occur. The total losses in a three-phase induction motor, we are divided into the position where it occurs, stator losses and rotor loss. Again, the stator losses can be divided into the two types. One is stator copper loss, another one is a stator core loss. The stator copper loss is nothing but when the current is passing through the stator winding, there is some amount of power will be wasted due to the resistance of a winding. That loss is nothing but a stator copper loss. Stator core loss. Whenever you are supplying a three-phase supply to the three-phase winding, there is a rotating field will be creating from the stator winding that is magnetizing and demagnetizing the stator core as well as the rotor. So whenever the stator core is subjected to the magnetic reversals, there is a some amount of loss will be occurs in the stator core. That loss is nothing but a stator core loss. Again, the stator core loss can be divided into the two types. One is the hysteresis loss, another one is the eddy current loss. We are reducing the hysteresis loss by selecting a material as a silicon steel. That material has a less hysteresis coefficient, so that hysteresis loss occurs in a stator core also we can reduce it. Eddy current loss. How we are going to reduce this eddy current loss? The stator core is made of the lamination, so that the eddy current loss also we can reduce it. The rotor losses is divided into the three types. Rotor copper loss. Whenever the rotating flux is creating from the stator, there is a rate of change of flux linkage in rotor box. The current is passing through the rotor box. When the current is passing through the rotor box, it has some amount of resistance. Copper loss will be occurs in a rotor box. That loss is nothing but a rotor copper loss. Next, rotor core loss. When the rotor is rotating, it will be rotating in a stator flux. It is subjected to magnetic reversals. So there is some amount of core loss will be rotor core. That loss are nothing but a rotor core loss. This loss is consisting of two losses. One is hysteresis loss, another one is the eddy current loss. But the magnetic reversal subjected to the rotor core in a running condition is very lesser. So we can neglect this rotor core loss when compared to the stator core loss. Next, windage and frictional loss. Windage is nothing but air. There is some gap between the stator and the rotor. The gap is filled with air. When the rotor is rotating, the air will be opposing some amount of force on the rotor. To overcome that one, there is some amount of power will be wasted. That power is nothing but a windage loss. Next, frictional loss. The rotor is supported with bearings. When the rotor is rotating, there is some amount of friction will be occurs in a bearing. So the some amount of power will be wasted to overcome that friction. That loss is nothing but a frictional loss. These are the different losses occurs in a three-phase induction motor in a stator as well as a rotor. Now we are going to see the power stage diagram. This is a three-phase induction motor. This is a stator. These are nothing but a stator winding. This is rotor. This is a shaft. These are the rotor bars. Whenever we are giving the three-phase supply, the flux will be rotating. Stator input. Nothing but electrical power we are giving to the stator winding. There is some amount of power will be wasted as a stator copper loss, and there is some amount of power will be wasted as a stator core loss. The remaining power will be available as a output of a stator, nothing but air gap power, nothing but a rotor input. There is no power is wasted in a air gap induction motor. Whatever the power is available at a stator output, that is the rotor input, because there is no power is wasted in a air gap. Now when the current is passing through the rotor bars, there is some amount of power is wasted as a rotor copper loss. Because the rotor is subject to magnetic reversals, there is some amount of power will be wasted as a rotor core loss, and there is some amount of power will be wasted as a windage and frictional loss, and remaining power is available as a shaft. The power which is available at the shaft only useful to drive the load. Now the air gap power equal to stator input power minus stator copper loss minus stator core loss. Now suppose if you want to find the shaft power equal to rotor input minus rotor copper loss minus rotor core loss minus wind agent friction loss. In this manner, you can calculate the air gap power as well as the power which is available at the shaft. Now we are going to find out the what is the relation between the rotor input, rotor copper loss, and gross mechanical power developed in a induction motor. See, this derivation is very important. The rotor input power, rotor copper loss, and mechanical power developed in induction motor is equal to 1 is to S is to 1 minus S. To derive this condition, we have taken so this is the circuit diagram of a rotor circuit which is operating at a stator frequency, nothing but supply frequency. E2 is nothing but a per phase rotor voltage at a standstill condition whose frequency is stator frequency, that is equal to supply frequency. That's why we are saying the circuit is operating at a supply frequency. The circuit is carrying a current of IR. This is the resistance, variable resistance. Its value is RR by S. This is the leakage reactance of a rotor, that is JX. Now, what is the power we are giving to the rotor? Nothing but air gap power or stator output. Because there is no power is wasted in a air gap of a induction motor. Now, the air gap power that is represented with a P suffix G equal to E2 into IR into cos theta 2. This is nothing but a voltage which is applied this circuit. IR is nothing but the current which is passing through this circuit. Cos theta R is nothing but the power factor of the rotor. So from this circuit, you can write the magnitude of IR. IR equal to this voltage divided by its impedance. E2 by square root of RR by S whole square plus X2 square. As rotor power factor cos theta R equal to this resistance divided by the impedance of the circuit. So this is equal to RR by S divided by RR by S whole square plus X2 square whole root. Now substitute these two equations in this equation. We are getting the air gap power equal to E2 into E2 by square root of RR by S whole square plus X2 square into RR by S divided by square root of RR by S whole square plus X2 square. The denominator, these two gets multiplying. So in the denominator we are getting the RR by S whole square plus X2 square. The numerator we are getting the E2 square. This E2 and this E2 gets multiplying E2 square into RR by S. E2 square by RR by S whole square plus X2 square to this quantity equal to IR square. Already we know the expression for the IR. IR square into RR by S. This is nothing but IR square into RR by S. Now the air gap power PG equal to P suffix G equal to IR square into RR by S. Now we are writing this resistance RR by S into the two components RR plus RR into 1 by S minus 1. This you can get it as RR plus RR into 1 minus S by S. If we simplify this one, we are getting the left hand side equation, that is RR by. Now substitute the equation 2 in a equation 1. Now we are getting the air gap power IR square into RR by S equal to IR square into RR plus RR into 1 minus S by S. Now you open this bracket. IR square into RR plus IR square into RR into 1 minus S by S. This quantity is nothing but a rotor copper loss. This quantity is nothing but a electrical equivalent of the mechanical power developed in an induction motor. Now the air gap power equal to rotor copper loss plus electrical equivalent of the mechanical power developed in an induction motor. Simply we are calling it a mechanical power developed in an induction motor. In place of rotor copper loss, we are taking the IR square into RR plus in place of mechanical power developed, we have taken the IR square into RR into 1 minus S by S. Now we are representing this rotor copper loss in terms of a air gap power. From the equation 1, the air gap power equal to rotor copper loss divided by the slip. So the rotor copper loss equal to S into air gap power. So in place of rotor copper loss, we have taken the slip into air gap power plus again in place of rotor copper loss, we substitute the slip into air gap power. That slip and the denominator slip gets cancelled. We have a air gap power into 1 minus S. So the gross mechanical power developed equal to this quantity is nothing but a gross mechanical power. Now here we have taken one equation, air gap power P suffix G is to Rotor copper loss S into Pg is to gross mechanical power developed is into 1 minus S. Divide the throughout this equation by air gap power. We are getting the air gap power is to rotor copper loss is to gross mechanical power developed equal to 1 is to S is to 1 minus. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel so that I'm always welcome to answer all your questions.